Hello, this is Jingjie, and here's my audience. Okay, so imagine one day in the future, all the electricity we generated from our energy plants can be utilized to 100% without any loss. Would that be a Would you agree that would be a very nice solution to the energy crisis we're currently facing? If so, I think superconductivity, which is the topic I'm going to talk about today, might be the key to make this imagination come true. So, superconductivity is a property of many materials that can be observed under certain circumstances. The revolutionary characteristics of superconductivity bring out potential that can change our everyday life immensely. And I was intrigued by this fact and did a lot of research on it. And here I want to show what I have learned so far. So today we'll go along with a timeline to learn about the past of the superconductivity and what we have achieved with superconductivity and how the future will look like with superconductivity. So superconductivity was first discovered in 1911 by a Dutch physicist named Henk Oens. It was cooling mercury down to around negative 269 degrees. Then he suddenly realized its resistance has disappeared. So this was human beings' first glimpse at superconductivity, and then for the next 50 years, many physicists have dedicated their work to unveil the mystery about superconductivity. Here I want to show a very interesting fact about superconductivity. As I am standing here right now, I might have not noticed, but there is a magnetic field flowing through my body. But if I can somehow cool myself down to a temperature low enough so that my body exhibits superconductivity, instead of flowing through my body, magnetic field will curl around my body, which makes me a magnetic insulator. And this is called Meissner effect. Meissner effect, along with other properties, took physicists almost 50 years to uncover. And for the next 50 years, with all they have known about superconductivity, scientists have started to wonder, what can I build with it? Which leads to my second point, technologies that utilize material superconductivity in different areas. In the article Superconductivity in Medicine, Jose Alonso and Timothy Atania use a portion of their article to explain the basic mechanics of an MRI machine. The magnet, which you can see on the screen, was powered by superconducting wires to create a uniform magnetic field in the chamber where the patient was lying. In advanced physics labs such as CERN, there are particle accelerators which use magnets that was also powered by superconducting wires that was used to stabilize and accelerate particles that are traveling in speed that is close to light. In the article, Potential Benefits of Superconductivity to Transportation in the United States, Donald Roth and Larry Johnson proposed this model of vehicles which also use superconductivity magnetic components as an energy storage unit. However, unfortunately, this unit is not applicable as of right now because of material and environment. Which brings me to the third point I want to share today, the challenges we're currently facing to find high temperature superconductors. S.R. Thornton and his peers discussed in their article that many materials only exhibit superconductivity in a very specific environment. Once that environment was changed, they no longer exhibit superconductivity, which makes this model meaningless. And the other challenge we're currently facing is between the balance between temperature and pressure. And scientist Jian and his peers discussed in their article the usual elements and other compounds that discovered that exhibits superconductivity only only shows at a very low temperature such as -20 degrees Celsius, which is nowhere to find in an everyday scenario. They found many superhydrates that indeed have some reasonable temperature that shows superconductivities. However, they are under a pressure that was over 100 gigapascal, which is a million times higher than the current environment we are living in. So with that being said, superconductivity has huge potential to solve many problems we are facing, improving our life in many ways we have never imagined before. However, it is also clear that we face a lot of challenges in finding high temperature superconductors. I hope one day when people are talking about breakthrough in superconductivities, you will know how much that will mean for us in the future. And this is James Gao. Thanks for listening. And here is my audience again.